the last of this twin. Geometric sequence has first term a sub 1 and fourth term a sub 4 equals 4. What is the sum of the first 6 terms of sequence? I can think of 3 kids who have this form down. But the form for a geometric sequence is that the nth term is the first term times a ratio raised to the n minus 1. I need that for this, okay? A sub 4 is 4. It is equal to the first term of 1 times an unknown ratio, n is 4, 4 minus 1. So 4 equals r cubed. Your ratio is therefore the cubic root of 4, which is an ugly number. It's a decimal, but that's the ratio. It's a cubic root of 4. What is the sum of the first 6 terms of the sequence? All right, so this is geometric. The sum of a geometric sequence. It's kind of funny. What is she? She's a sub 1, parentheses with a fraction in it, 1 minus r to the n over 1 minus r. Now I'm just going to plug stuff into it. A sub 1 is 1. 1 minus the ratio, which was the cubic root of 4, and I got to raise it to this nth power, which is 6, over 1 minus the cubic root of 4. That is going to be a funny looking answer, but that's what it is. You might see this rewritten as, they probably dropped the 1. 1 minus 4 squared. 6 over 3 is 2. And you might see them rewrite this as 4 to the 1/3. You might see something like that. Anyways, that's how you do 31. 32, the points a equals root 3, 1/2, and b equals negative root 2. Root 2 both lie in a circle whose equation is x squared plus y squared equals 1. That's really cool because they're telling us that this is a unit circle with a radius equal to 1. What is the length of the longer of the 2 arcs of the circle having a and b as endpoints? Really? Huh. Well, how about that? Was not expecting a question like that. Now, believe it or not, this is supposed to be taught in 10th grade. It isn't taught in 10th grade. I understand why it's not. You know, a lot of your teachers actually, believe it or not, play a balancing game with trying to teach you and not fail you at the same time. I included, believe it or not. Root 3 1/2 would be about right here. And it would represent a 30-degree angle. This is going to seem kind of funny. I'm trying to think how I can relate this to you guys, but you just don't know enough yet. You would go right root 3 over 2, and you go up 1/2. Maybe try and think about triangling it out. And you'd be like, okay, this is interesting. There's a tangent ratio. The arc tangent of 1/2 divided by root 3 over 2. Oops. Is 30 degrees. That's what she is. So let's start thinking about our circle here. This is a 30-degree angle. I'm just going to put 30 degrees off to the side. I'm going to do the same thing over here. This should be a 135-degree angle. The arc tangent of negative root 2 over 2, oops, divided by positive root 2 over 2, which is 1. Should be a 135-degree angle. Oh, they said negative 45. But that's not right because that's down here. It would be back over here. You see, a calculator doesn't tell you everything. But to get to this point, you've got to run left and you've got to run up. That's a 135-degree angle. So I can't even show you how to do it in a calculator. It's just trig, and you weren't taught enough of it. What do they want here? They want to know which arc is longer, this one or this one. It's going to be the bottom one, isn't it? If a full circle has 360 degrees of separation, you've got 180 here, you've got 30 there, and you've got another 45. This arc has quite a bit of separation. It's 255 degrees. Now, on your form quizzes, I put something on there a little bit different than I have been in the past. I usually don't teach it this way. Let me go get one. Somebody cleaned up my room yesterday. I do. Look here. I usually teach a different formula, but I thought I would try to keep things more in line with how you learn them in geometry. Arc length of a circle, theta over 360 times 2 pi r. And there's an or statement, which a lot of you aren't using, but arc length S is theta over 360 times 2 pi r. The angle is 255. The radius is 1, and you have 2 pi. So all we're going to do is we're going to take 255, divide it by 360, convert it to a fraction, 17/24 times 2, I guess I need to write it. 2 times 17 is 34, 34 pi over 24, reduces again, 17 pi over 12. Believe it or not, this is a 10th grade standard. It's not an 11th grade standard, it's a 10th grade standard. The function f of x equals 3x plus 2 over 4x plus 3 has domain all values of x such that x is not 3/4, because if x was negative 3/4, that would be 0, and you would be dividing by 0. What is the value of the inverse of f of x? That's what they're actually asking you to find here. I want you to find the inverse. All right, to find an inverse, first thing we do is we swap x and y. So this y becomes an x, that x and that x become y's. And then we resolve for y. What I'm going to do is I'm going to 4y plus 3 both sides. I'm going to invoke the distributive property. 4yx plus 3x equals 3y plus 2. And I'm going to move everything with a y to the left and everything else to the right. We've done this before. 4yx minus 3y equals negative 3x plus 2. I'll pull the y times 4x minus 3 equals negative 3x plus 2. And I'm going to divide all that out. So y is negative 3x plus 2 over 4x minus 3, and that's my inverse. Swap x and y. Sorry you couldn't see all my work. Resolve. If log base 2 of x equals log base x of 4, what is the set of possible values of x? Do the same thing I did earlier. Log base 2 of x equals log base 2 of 4 over log base 2 of x. Oops, sorry, you can't see. It'd be a lot easier if this was multiple choice, but it's not. Actually, I think I'm just going to redo this. Log base 2 of x says what power of 2 creates x? Log base x of 4 says what power of x creates 4? So the left-hand side is really saying 2 to what power of y is x? And the right-hand side is literally saying x to what power is 4? Kind of funky, isn't it? Now I can use substitution here. If 2 to the y is x, I can put it right there. 2 to the y times y is now 4. 2 to the y squared is 4, and 4 is 2 squared. So y squared is 2. Counteracting squaring by square rooting, y is root 2. Root 2 is what I'm looking for. Funny answer. Each spring, Jessica, Sam, and Michael work together to score the TMTA high school math contest exams. If Jessica and Sam work together, they can finish scoring in 2 hours. Oh, word problems. If Jessica and Michael work together, they can finish in 90 minutes. Sam and Michael are the slowest. If they work together, it takes 3 hours to finish. How long would it take all 3 of them if they work together? So we have work problems here. And these things work as such. 1 over time 1 plus 1 over, and I forgot the x, times some unknown, times some x plus 1 over time 2 times some x is 1. Where x is time to complete. So we talk about Jessica and Sam working together. They can finish in 2 hours. So that becomes 2 over time 1 plus 2 over time 2 is 1. If Jessica and Michael work together, see, Jessica was time 1, Sam was time 2. Next one is time 1, and Michael will be time 3. So 1 over time 1, 90 minutes, 1.5 hours, plus 1 over time 3 equal to 1. Second equation, 1.5 over time 1 plus 1.5 over time 3 is 1. They can finish in 90 minutes. Sam and Michael are the slowest if they work together. Takes 3 hours. 1 over Sam, who is time 2, times 3, plus Michael, who is time 3. 1 over time 3 times 3 is 1. Kind of rough, isn't it? Creating systems of equations. 3 over time 2 plus 3 over time 3 is 1. There's my 3 equations that are going to enable me to solve for time 1, time 2, and so forth. Blah. They're horrible. And I'm going to take a small break before I finish this one, because my mind is exhausted.